cranking operation. Then he is lifting component from the pallet, processing it on the press and keeping it in the pallet. So this job he is constantly repeating and repeating. Then maintain certain phase, the certain stressful postures are repeatedly maintained for a long period of time. Consider if somebody is picking something from the pallet, he is putting and placing it on the press. Then in that case, that is the stressful posture that he is repeatedly maintaining. These movements or postures which are harmless if you do it once in a while or briefly, but if they are repeated on the daily basis, these can result into injury. Repeated application of force that is not strong enough to cause immediate damage, but over a period of time it is going to fatigue the tissues, and after a period of time there will be pain as the tissues involved, that is the when we talk about the human bodies, the tissues involved are the skin, the muscles, the tendons, the joints, ligaments, nerves and the blood vessels. They are repeatedly rubbed, compressed and stretched from the movement and the exertion that we expose our human body to, and if the tissues are not allowed to recover, then this will result into cumulative damage and or the ergonomic injuries. Then again, if we talk about the forceful exertions which come on our body, we exert force on our muscles. In case if we have to move our limbs or lift or hold an object, we are applying a force from our muscles. So this forcefulness is again a risk factor when we are talking about the cumulative trauma disorders. As muscles contract and relax, the tendons are stretched and they rub and press against the adjacent tissues, and these are called as the musculoskeletal strain, and it depends on how much force is being applied, how much force you are exerting from the body, how much weight you are lifting it, and force is that amount of work which muscles, tendons, joints and adjacent tissues must do in order to perform that particular action. The force exerted again depends upon the posture that you are having, the weight and the friction that is there. Now I will cite you one example, the importance of the force and the posture. Now look at this picture. In case you have to lift a book, and if you lift the book with the help of your fingers, that is the pinch position if we are talking about, you can just try it for yourself. If you lift the book in such a way, you would not be able to lift it for much of time. That means you are exerting force on your body. Whereas if you hold this book or lift this book in the hook position, the weight of the book being same, but the design in which the posture in which the book is now being handled is much more comfortable. So while we are designing our work, we are designing our workplace, we have to look into these situations, how the operator will lift his component, how will the operator hold his components. So we have to see what type of grip he is going to put from his hand. So this pinch position type of grip is to be avoided, and the hook position type of grip is to be given to the person. So this is not ergonomically correct design, this is the ergonomically correct design. So you can perform work more efficiently with some postures than others, and in certain postures you have to exert much more force to do the same job. Then for the forceful exertion, some more points to be considered. The weight of load to be moved, how much weight is going to be moving. All things being equal, a heavier load will require greater force to manipulate. If the object is being moved which is a slippery, if the floor is slippery and person has to move the component or the weight, that means he will have to exert more force through his hand, and similarly on the slippery force, more force will be required to push. The hazard from the force depends upon the part of body which is involved, what kind of movement is involved, and the repeated again we are talking about. Now we as we talked about the postures. Now stressful postures. The posture is a very important factor in the ergonomics injuries. Posture is critical to ergonomics and affects various parts of the body. Now if we talk about the hand postures, most efficient hand posture is the power grip. You can see the component or the tool, like this is the hammer if he is using. Look at the grip. His fingers and thumbs have firmly gripped it from end to end. So this is called as the power grip. Again, this is some pneumatic tool. Good level of grip has been provided. Now this pinch grip. This pinch grip is best for the precision task. In case we have to do some precise job, some electronic equipment assembly, then only this grip should be used. Otherwise the power grip is the best, and replace the pinch grip with power grip if the work being done is not very precise. Remember, while we talking about the hand postures and the grip, we should provide good grip on the objects. That means the person is able to hold it comfortably with a good level of grip, so that he is to apply less amount of force in holding the tool. If this is slippery, he will have to apply more force. So avoid slippery handles, provide a good grip, increase friction by providing tool handles with textured or coated handle coverings. Maybe covers you can provide. Even we use cover on our steering wheel to give a good grip. Knurling can be done on the handle to provide good level of friction, and also you can, in case you want, you can use non-gloves. You can use gloves which are non-slippery. Now look, that was the hand posture. Now look at the wrist posture. Now when we talk about the wrist posture, so this is our wrist, and when our hand is straight with the wrist, this is called as the neutral position, and here we are not at all posing any stress to our wrist. Now this again is a neutral position wherein the hand is straight and no level of stress is being pushed. So non-neutral wrist postures are potentially stressful. Let us have a look at the other slides. Now this is the wrist, and when the hand is bent backward from the palm. So here you see this is the hand, but now the hand is bent. Here the wrist is exposed to the stress. So this is the stressful wrist posture. Again in this case, when the hand is bent towards the palm, again here we are exposing our wrist to the stress. So this is again the stressful wrist posture. And here we see, but here the hand is bent toward the little finger. You just see over here, again the wrist is at the it is being exposed to the stressful posture. And now when the hand is bent towards the thumb, again here we see that this is the stressful posture. So these are the postures that we have to identify at the shop floor, and how we can provide him the comfort of making the hand, that is the wrist, in the neutral position. So this is the center position is what is desired, and we have to avoid postures like this where the hand is bent. Here we see the hand is bent, here we see the hand is bent, here it is bent, here it is bent, and again we have to avoid the pinch grips. So these are the stressful ergonomic position with respect to the hand and wrist postures. Now look at the shoulder posture. Now if the person hand is straight to his body in this way or in this way. Now as the hand is raised to the upper side or on the side like this or like this, with every increase in the angle from here to here, our shoulder is getting stressed, our lifting capacity is getting reduced. So here if we have the maximum lifting capacity, and here we see when the arms are fully extended, the strength or the lifting capacity reduces by almost 80%. If we are here able to lift a 50 kg load, in this case we can only lift about 10 kgs of weight. Almost 80% reduction in the lifting capacity. So these are the stressful shoulder postures. If we have to use such postures, we have to be very careful to identify such postures, and ultimately we have to eliminate these, reduce these, or they will result into ergonomic injuries. Now look at these neck postures. So just see an example over here. A person is reversing. If a person has a material on the fork, he has to reverse the forklift. When he has to reverse the forklift, he has twisted his neck. So if such situation is there, then we have to see that his neck is under stress. So this is the straight posture, and as the neck bends either forward or the backward, and if this bending is more than 20 degrees centigrade, 20 degrees, that means our body is exposed to stress. So this is the stressful neck posture, in which the head is bent 20 degrees either forward or backward, or it is twisted. When we twist the neck, as in this case when the person is reversing the forklift, that means his neck is under stress, and the side to side movement or excessive twisting, when we say it is excessive, means it is 2 times per minute, and in such a case again the person is going to be exposed to the ergonomic injury. Now we talk about the fourth risk factors in the ergonomics, that is the mechanical stress, and it is produced by contact between part of the body and the sharp edges of the tools parts and the work surfaces or the work pieces. Now here we consider an example which has the tool has got the sharp edge. When the person is using a tool with a sharp edge, we can just see how the skin has got pressed from here. Now see these type of postures, as I have already mentioned, will only be result into the cumulative trauma disorder depending upon the repetition, depending upon the duration. So this is very much important that such a tool is having the sharp edge, it is pressing on your skin, it is ultimately touching or harming your tendon, and owing to the repetitiveness, owing to the duration, owing to the amount of force being exerted while using this hand tool, it will result into the cumulative trauma disorder or the ergonomic injury. Now at the same time, if instead of this sharp edged tool, we have a round edged tool, instead of the sharp edged tool we are having a round edged tool handle, then what is going to happen is, you can just look at the picture here, there would be very less damage to the tendon below the skin. So these are the things very simply we have to identify at the shop floor, and we have to take these up for the corrective actions. And hand tools of course are the common cause of the mechanical stress, but the other body parts sensitive to mechanical stress are the backs and sides of the finger, insides of the wrist, front of the lower leg, elbow, tops of feet, and the soft tissues of the thighs during the prolonged sitting. Now, fifth factor is the temperature extremes. Now, extremes of both cold and heat can be stressful. Skin temperature should not be allowed to fall below 20 degree due to contact with air or the ambient environment. See, cool condition often, the cold condition can impair the sense of touch and the dexterity in the hands. When holds are cold and they are numb, you misjudge the amount of force necessary to perform a task. In such a case, if you are repeatedly working when your hands are cold below 20 degrees centigrade, you may not be able to judge the amount of force which is required to do a particular work, and you may be exerting more force. Forcefulness would be there. Then there are overexertion to your body. You are applying more force from your body than required, and this can result into the ergonomic injury. Then the heat which is there, of course, it can cause the burn injury from the hot surface of the components that are there, and also it can result into heat stress and the heat stroke. Environmental heat, especially accompanied by high humidity, can increase the strain, that is the heat stress, and muscular, when you are doing the activity, that is the muscular activity is producing heat, and in high temperatures and humidity, body has to work harder to give off more heat. That is, the excessive stress is caused on body in working in hot and humid working conditions. Now the sixth factor that we talk about is the vibration. So use of hand tools, pneumatic tools is very common in the industries, but when we are using these, if these tools are not properly maintained, then these results, the hands are exposed to the vibration. The vibration through hands can cause damage to nerves. It can cause damage to blood vessels and bones of the hands and arms, and this can come from the different type of the pneumatic tool which is being used. And even exposure to the low frequency vibration can cause ergonomic risk to the back of the person. It can cause back injuries. E.g., person who is driving forklift, he is continuously exposed to the low level of vibration when he is sitting on the forklift seat. Similarly, person who is driving a reach truck, again is exposed to the low frequency of vibration, and these can again, the vibration can again cause an ergonomic injury. So all these 6 factors have to be looked into, that is the repeatedness which is there, the forceful exertions, the body postures which are there, then the vibrations, the heat and stress which is there at the shop floor. All these 6 risk factors have to be looked into while considering the ergonomic injuries, and these ultimately results into cumulative trauma disorders. And all these things fine, but as you know, age of the person, the fitness level, history of injury, medical condition, and the non-occupational activities, how much exercise you are doing, what is the other work that you are doing beyond the working hours. If person has got some medical history, he has got some history of injury already there, his person's age is more, fitness level is not good, then all these factors can affect the person more early than a person who doesn't have these disorders. Now, very important, when we talk about the ergonomics, immediately we talk about the low back problems. So if we look at our spine, this is our spine, or this is our backbone. So spine actually forms a stretched S level curve. Actually, this is a S level of curve, and it consists of 33 bones. Our backbone or the spine, it consists of 33 bones, and they are called as the vertebrae. And these, each of these vertebrae, that is the 33 vertebrae, are separated by discs. There is a disc through which these are separated, and each vertebra is supported by a facet joint to which the muscles are attached. So if we say this is our vertebrae, and here we have got our muscles or the facet joint. So these are the spine muscles, and this is the vertebrae, and this is attached to the facet. So this is what is the structure when of the 33 vertebrae. The upper part, that is at the neck, it is called the cervical. Then at the chest we have the thoracic region, and at our waist, that is the lumbar region, we have got these L1 to L5 5 vertebrae which are called at the lumbar region, and then again at the bottom we have. So this is the structure of the spine, very very important. And the spine, you know, it houses the spinal cord. Spinal cord is very very important part of the central nervous system. It gives controls to your body through your mind. Then the backbone, along with the support of the muscles, keeps your body in the upright position, and also it is through these muscles and through these vertebrae that you are able to lift weight. The weight lifting capacity depends upon the muscles and this strength which the spine muscles have. So it is very very much important to understand the structure of the backbone and how the low back problems are caused. Now, when persons are repeatedly bending, they are repeatedly lifting the weight, ultimately what happens is these forces, they eventually weaken the disc. When these eventually weaken the disc, and at the same time, due to repeated movements, that is the repeatedness which is there, the duration which is there, it causes a fracture, or it ruptures the disc wall over here. Now here there is a muscle which is keeping your disc in the normal condition. In the normal condition, when the muscle is here, when your the disc wall has not torn off, then this disc remains inside. But owing to the repetitive exertions which is exerted on the spine muscle, and because of the fatigue and the strain, this particular muscle, it gets ruptured from here, and this disc, it comes out. It protrudes from the vertebrae, and it starts touching this spinal cord which is there. The nerve which are passing inside, the nerves which is passing inside the spinal cord, it starts touching to that. The moment the nerves which are passing for the central nervous system, it gets compressed. The moment this disc comes on this central nervous system spine over here, then it presses the nerve. The moment the nerve gets pressed, you start experiencing pain on your lower back pain. It will depend on how much it has come, how many of these have got damaged. So this is known as the slip disc. Slip disc, everybody is well aware about these happen, but why these happen is because this muscle has ruptured and this has come out. And if this is not rectified timely, then you can you will continue to have this slip disc problem. And the slip disc conditions involves your nerve compression, pain, and the distortion of the ligaments of the vertebrae. This is what we are talking about, the ligaments, the muscles which get ruptured over here. Now for the low back pain, there are two type of people who are at the greatest risk. One is the manual material handling, that is people who are involved in lifting heavy objects, moving and lifting bulky objects, lifting objects from the floor. That is people who are involved in the material handling. And then the stressful postures, people who are sitting in the office in the poorly designed seats. That means the two type of people, that is people who are sitting in the office whose chairs are not ergonomically designed, they are not using the proper postures while sitting, and then the group of people who are involved in the material handling. So these are the people who are exposed to the low back problem. And the statistics says that 7 out of 10 people, they have or they will suffer from low back pain at some time in their lives. Now now let us consider one more example, that is example of a simple lever. See, if this is a lever and this is a fulcrum, and now the fulcrum is at the center, and if we have to balance the 20 kgs weight over here, simply if it is in the center, we need to put a 20 kgs weight or a 20 kgs effort, and you can easily balance the lever. So that means in this case only 40 kgs of weight is coming on the system. But now see just what happens when the fulcrum is shifted towards the back side. That means here we have a 2-inch distance and here we have a 8-inch distance. The moment the lever fulcrum comes over here, now if we have to balance this 20 kgs load, it can only be done when we put a 80 kgs load over here. So the moment we see if the fulcrum gets shifted and we have to balance this 20 kg load, we have to place an 80 kg weight over here or an 80 kg effort. That means overall effort which is coming on the system is 100 kgs. Now look at another example in which if we increase this length. So here we have just 2 inches of gap from the on the lever with respect to the other end at the fulcrum, and here we increase this gap, and now if we have to balance a 20 kgs of load, that means in that case we have to put almost a 200 kgs. So now we see this 20 kg load with respect to this load, the position of the fulcrum, the length getting changed, we have to put more and more load to balance this. So for this balancing over 20 kgs load, we have to have a 200 kgs of effort, almost 220 kgs load is coming on the system. Now same way, why I took this example was to explain how this lever effect works on the human model. Now this is our spine. We are standing straight with hands close to our body. So with this is our spine, we say this is our fulcrum, and this is our muscles almost 2 inches from the spine. Now here if we have a 20 kgs load, we are standing erect. That means to balance a 20 kgs load, we have to exert a weight of 80 kgs from our spine muscles to lift this 20 kgs load. So that means the overall effort which is coming on the human body is 100 kgs. So that means you can just imagine while you are putting or lifting a 20 kgs weight, you are actually exerting a 100 kgs of force on your spine, and this particular is your L1 to L5 spine area, that is the lumbar area where the backbone or the low pain, low back problem exists. Now if you consider an example in which you have stretched this hand. Now you have, when the moment you stretch this hand and the moment the hands goes away from your body, you cannot lift it in the erect position. You have to bend forward. The moment you bend forward, but you see a situation wherein this has come over towards the other side of the fulcrum. Here your spine is straight, but here the spine has come on the front side. So for lifting a 20 kgs weight, if you bend your body, then the weight of the upper part of the body also gets onto this lever. So here we say the moment you bend with the same amount of load, in case of bend condition, what happens is, if we take the upper part of the upper weight of the body to be 20 kgs, so we have a 40 kgs of load and the 400 kgs of weight is exerted. So to hold a weight at some distance from our spine, we must exert a lot of force. So that is why it is said to hold the load closer to body and keep your body upper and erect as far as possible. So now you can see, if you are bending with the lifting with the bent back, then what is going to happen is, if you look at this example, you will just see that here it is, here your discs are there and here they are getting pressed. So here you can look at an example. Just see over here. Here it is, here the between the two vertebrae, your disc is getting pressed. The moment it is getting pressed, you are going to again get the slip disc. It will here it is getting pressed. It will protrude from here, and because it will damage this ligament, and ultimately this is your spine, the central nervous system, cords which are passing, the nerves which are passing, and it will ultimately result into your low back pain. Even sitting or standing without handling a load, but when you are bending towards the forward, it can cause a problem. So this is the right posture of lifting, wherein your back remains straight. So just to sum up some of the ergonomic risk points that we discussed, that please avoid stressful hand and the wrist postures. Please avoid those postures which are causing bend on your back. Just look at here, if the load you are lifting is away from your body, that means you are exerting your body to a force, and you are going to likely have a back problem, and this is possible on conveyors, tables, racks. So the different examples are given. This is very much common example. And then twisting and turning, that in case you are transferring a product from conveyor to a pallet, in case you are constantly twisting and turning your back, then if the shoulder is too high, again you are exposing your shoulder to stress. The comfort zone, when you are working, the assembly stations, they have to be well within the reach of your hand, and you have to identify such conditions to rectify. Again, we talked about the bent wrist, hand postures, elbows out. Again, this is an stressful posture. Neck is bent during the inspection process. Again, this is an stressful posture. It is an ergonomic risk factors. Again, the vibrations are the risk factors. This is an ideal office chair. Your back is straight, your foot is resting on the floor, they are not above the ground, back is perfectly straight, monitor is straight in the front of your eyes, and just look at the wrist. Here the wrists are neither bent up or bent down. So these are the things we have to consider while designing an ergonomic office and the chair. Then just to conclude, keep everything in easy reach, work at proper heights, reduce the excessive force to your body, work in good and correct postures, reduce excessive repetition, minimize the fatigue on human body, minimize direct pressure, proceed for adjustability and change of posture, provide for clearance and access. This is just to sum up, and this was from my side, and I do hope that you would have found this session interesting, and I did quote examples from the factory, from the working atmosphere. You can note these, identify these unsafe ergonomic conditions at the shop floor, take up these for rectification, so that we can ultimately provide the place which is safe for the people to work into. Unlike injuries, we cannot identify. If the injuries happen, you immediately come to know. But if somebody is developing pain on the neck or the lower back pain, we will not come to know instantly, but we have to identify such situation. So that is from my side, and in case you have any questions, I would be glad to answer those. Yeah, please, in case the audience which is listening, it has any questions, we can take up those.